internal resistance of a circuit. The internal resistance of a circuit, that is where the question is taken from. A cell of 1.5 volts is connected in series with a resistor of resistance 3.0 ohms, a voltmeter connected across register 0.9 volts. Calculate the internal resistance of the cell. So we're going to calculate the internal resistance R of the cell. So let's quickly do a schematic representation of this. So if we go drawing this, it's very simple. We're going to take this, draw a cell, an external resistor, okay? Down, this is the internal resistance of the cell. We have a switch here, right? Okay? And then we have a cell here. And then somewhere here we have small internal resistance. Okay, this is R, and this is capital R, right? And so on and so forth. When the switch is closed, current flows. Alright? I think this is what this represents. External resistance is this, and this is 3 ohms, 3.0 ohms, right? So we are going to look for this internal resistance of the cell. The cell is recording what? Or registers 0.9 volts. Okay? So let's begin. What we need to do now is that, first of all, from this thing we have that the cell, okay, is 0.9 volts. Okay? That's the first thing. Then E is 1.5 volts. We're just bringing out data. Okay, let's just see what we have here. Data. Okay. And what next? We don't have current. Current is unknown. Alright. We're going to look for that. Unknown, measured in ampere. So what next? External resistance R, external resistance. External resistance R is given as 3.0 ohms. Okay? So what next? We are looking for internal resistance of the cell, right? So we have internal resistance is given as unknown because we don't know the value. We don't know the value, and it's measured in ohms. Okay? Alright. So if that is the case, what we need to do now is to find the value of current flowing first. If we find the value of current flowing, then we'll be able to find other things. And how do we get this? We start by stating Ohm's law is V equal to current flowing and then R. Alright? Okay. If we make current the subject, we have I is equal to V all over R. And then V here is 0.9. And then R is just 3. Definitely current is going to be I is equals to 0.3 amps. Good. So we have found the current to be 0.3 amps. Okay? That's it. The next thing we are going to do, so we now have that current flowing is equal to 0.3 amps. That's it. So check very well. 3 divided 0.9. Of course, 3 divided by 9 is 3, so it's going to be 0.3 amps. Okay? So we now know the current flowing. The next thing is we need to find out the formula connecting the internal resistance of the cell. That's what we need to do. And that becomes E is equal to, let's see how it goes. If that becomes E is equal to I, the current, alright? And then bracket R plus R, yes. External resistance and the internal resistance. For E, we put 1.5, okay? 1.5. Alright. And then for I, we have 0.3, good. 0.3. So let me write it well so you can see it very, very well. Let's repeat this once again. We have for E is 1.5, 1.5. For current is 0.3 brackets R plus small r bracket close. Okay, so we are going to open the bracket. That's the first thing here. So we have 1.5, all right, is equals to 0.3 times this is going to be 0.3 capital R for the internal resistance, right? Okay. We already know what internal resistance is. Okay, we can simply substitute for the internal resistance. Let's just substitute and see what we have there. Yes, we can simply do that. The internal resistance is giving us 3. Can you see that? Look at it. It's giving us 3 ohms. So we have 0.3 ohms. Sorry, we have 3. Yeah, just 3, okay? And then we are looking for the internal resistance 3, okay? We substitute here for external resistance 3 ohms. That's what we have here, okay? And then the internal resistance is the one we're looking for. So what do? We clear outwards again. We have 1.5 is equal to, we have this times that. So let's see, this times this is 9 points, that should be 0.9. And finally we have plus 0.3 R. Okay, that's it. Alright, that is it. So we have this, and for having this we have 0.5 is equal to 0.9 plus 0.3 R. So we can now make R the subjects. If we make R the subjects, we find out that this becomes, this comes here, we have 0.3 R is equal to 1.5 minus 0.9. Okay? Okay, with that, the next thing we need to do is to make this. Once we make this the subject, we have the value of internal resistance of the cell. So let's just quickly do that. I don't want to clean the diagram, so let's quickly do this. We have this here, and then we will now find the value of the internal resistance. So if we have 0.3, small r is equal to 1.5, and then what happens next? Minus 0.9. Definitely what remains here is very simple. We have 0.3 r is equal to 1.5 minus this is going to give us 0.6. Okay. And by the time we divide all through, by 0.3, we will now have only the internal resistance remaining, which is 0.3 over 0.3 is equal to 0.6 all over 0.3. And definitely by simple cancellation, this we cancel this, and what happens? We are now left with just the internal resistance here, right? And that is R is equal to 0.6, I repeat, 0.6 all over 0.3 is simply 2. Internal resistance is measured in ohms. Okay, anything resistance, whether it is external resistance or internal resistance, it is all measured in ohms. So that is what it means. Okay? We have now successfully found the internal resistance registered in this circuit. So this R has been found, okay, according to the question given. This is indeed a standard question, WAEC question, NECO question, JAMB question. So if you don't understand this, you can as well do me a comment in the comment section, and then we'll discuss it further from there. That is how to find the internal resistance of a cell. That is how to do that. So I'm going to sign up now. See you in my next class.
I'll go ahead and